So in this lecture, we are going to start with destructors. We have learned constructors. Now what destructors do? They destroy the objects created by the constructors. We know that to create objects, constructors are important. To create object, constructors are called. And to destroy the objects, the destructors are called. So a destructor is a mechanism which automatically destroys an object when it gets invalid. So, when there is no constructor is declared or defined in a class, the compiler automatically provides the constructor. It is implicitly available. Even if we don't specify the constructor, we don't declare the constructor or define the constructor in a class, the constructor is automatically available. The constructor is automatically available in the class. Likewise, when we don't specify the destructor is automatically available in the class. And if you want to define and declare the destructor in a class, you can do that. So when there is no need of the object which was created is no more required, that time destructors are called to destroy the memory which was allocated to the object. Or an object, when it gets invalid only when it is not required, or for example because of leaving its scope means when we create an object in a main function, the scope of that particular object will be a main function. When the main function ends, then the scope of the object ends, which means it leaves its scope. So here in this example, if I have created an object obj1, when this main function ends, as soon as this main function ends, the scope of this object also ends. So after this, the object will be, or object should be destroyed, because then the object 1 is not required. So there is no point for obj1 to occupy a particular memory space. So obj1 will be destroyed as soon as this main function closes. Okay, destructors are used to release any resources allocated by the object's constructor. That's what it means. What is the foremost resource which will be occupied by the object? A memory. So the memory will be released as soon as destructor is called. So destructors are used to release any resources allocated to the or allocated by the object's constructor. Constructor allocate the memory to the object. Destructor destroys the memory allocated to the objects. The usual resource being acquired in a constructor and subsequently released in a destructor is dynamically allocated memory. Yeah, so it's talking about memory. Dynamically allocated memory because that the memory is automatically been assigned to the object and automatically been destroyed by the object. So it's known as dynamically allocated memory. You don't call them explicitly. Explicit means when the user specifies the destructor in the class. But till now, the example which we have seen till now, there we hadn't used any of the destructors. It was implicitly available. So we are not supposed to explicitly declare and define the destructor. It is implicitly available. The system provides it. The compiler provides it. The developer do not have to specify the destructor. But if the developer wants to specify explicitly, he or she can do that. So actually you don't call them explicitly. They are called automatically for you. And there is only one destructor for each object. For each object, there is only one destructor. And the name of the destructor is same as name of the class. So let me start with the example first. This example which is given in your textbook, example 12. So this is the same example. In this example, you will find that the header files are used. Class ABC is declared. This is the body of class. This is the body of class. The class is starting here and ending here. This class has two data members, width and height. Actually, they are acting as pointers because width data member is preceded by dereference operator and height data member is preceded by dereference operator, and the data type is int. So these two data members are actually pointers, and which is private. When no access specifier is specified, that means by default it is private. Then in public, there is a constructor. Why this is a constructor? Because this function having the same name as that of class, it do not have any return type, and it has got two parameters. That means this is a parameterized constructor. And we have only declared the constructor, and when here class is ending. But if you'll check, this constructor has been defined from outside the class. Okay, so we have just declared the constructor inside the class, and we have defined it outside the class. Okay, and this is an example of destructor. Here also the destructor is been defined inside the class. Declared inside the class and defined outside the class. So how I can make out that this is a destructor? Destructors have the same name as class preceded by tilde sign. This tilde sign. So this becomes destructor. If you want to define this destructor inside the class, then what you will do? You can write the body of the destructor after this also. Like this. And if you want to define the body of the destructor from outside the class, then what you will do? You will use semicolon, the destructor name preceded by tilde sign, scope resolution operator, class name, the class name is ABC, and destructors do not have return type. So no return type here, because destructors do not return anything. Same as constructor. Constructors also do not return anything. So next function, the member function of class ABC is area. Okay, and it is going to return an integer value. What is there in the body of area function? It has got return statement which is going to return an integer value. Which integer value? The value of pointer width into value of pointer height. The result which is going to return will be, the value it is going to return will be integer value. That's why the return type of this area function is int, and the class is closed. And we know that constructors have same name as class. Since it has got two parameters, this is known as parameterized constructor. Constructors do not have any return type, that's why there is no return type here. And it is been declared here inside the class and defined outside the class. So same method, constructor name, the constructor name, scope resolution operator, because we are defining this constructor from outside the class name, and here should be the return type, but constructors do not have return type, not even void. That's why there is no data type. Okay, and this is the body of the constructor. And if you want to define it here also, you'll have to remove the semicolon, and you can define it here also. Okay, it's your choice. In this program, the constructor and the destructor are been defined outside the class. Then the main function. The data type of the main function is void. So what is there in the main function? CLR, SCR, clear screen, and then two objects are created, obj1 and obj2. Okay, this is known as instantiation of the object or creation of the object. Class name, object name, we are creating the object 1 and obj second object which is obj2. Here this statement is going to print something, this statement is also going to print something, and the get ch. So expected output of this program should be what? I'll show it to you. Now, the execution of the program always starts from the main function. So whatever is there in the main function will execute. So clear screen, we know it's used to clear the output screen. Then we have created an object obj1. So as soon as we create an object, constructor is called. And this constructor matches with this constructor. It has got two parameters, this also has got two parameters, and the values are integer, and the parameters are also integers. So this means 3 will be passed to A, 4 will be passed to B, and inside the function what is there? As soon as the object is created, the constructor is called. So whatever is there in the constructor will be executed. So what this statement mean? So I want to explain something. Before explaining these statements, here, we have learned about pointers already. We have learned two ways of declaring a pointer. The two ways which we have learned is something like this. Suppose I want to have some pointer, for example, B. Before that, some variable is there, int A, and the value initialized to A is 2. B is a pointer. We know pointer is a variable which points to the address of another variable. So, I have declared a pointer, but pointer should point to an address on another variable. So this statement should be used. B is equal to and A, or you can say ampersand A. A is a reference operator. When a variable is preceded by ampersand, that means it is talking about the address of variable A. So B, which is a pointer, is pointing to address of variable A. And when we use the statement cout, value of B is star B. So value of B will be 2 because B is pointing to variable A. So value of B is 2. And if I will use this statement and I will not use star before this, then B will print the address of variable A. So B will print the address of variable A and star B will print the value of A. This I have told you before also. There is the same thing. I'll put this into comments. Okay, it is in comments now. The another method which we had learned, how we can, for example, there's a variable A and I want to have a pointer B is equal to and A. This is another method with which the pointer B points to the address of variable A. Either you can use these statements or you can use these two statements to create a pointer and allow the pointer to point to an address of a particular variable. Now, there is one more method with which we can create a variable, we can create a pointer. So we can use the pointer, we can create, there is another method of creating a pointer, the third method which I am going to show it, the method which is used in this program. First, I will execute this program. Suppose there is a variable int A is equal to 2 and there's a pointer B. Okay. Now I want this pointer to point to variable A. So we can use a new operator. We can use a new operator like here we have used. So what we are going to do, B is equal to new, B is equal to new int. Why int? Because this pointer is going to point to a variable A which holds integer value. So this pointer B needs to point to variable A. So we have used new operator and the data type for A is int. That's why int is used because B is pointing to a variable A which will hold integer value. That's why the int will be used. And the next statement will be star B is equal to A. So we can, this is the third method with which we can use the pointer which will point to an address of another variable. So this method is used here in this program. So where were we? We were creating an object obj1. So as soon as the object obj1 is created, it will call the constructor, this constructor. 3 is passed to variable A and 4 is passed to variable B. And we know that width and height are the pointers. And we also know that constructors are used to initialize the data members of the class. So width and height are the data members of the class, or we can say width and height are the pointers, which are the data members of the class. So these are the pointers. So 3 is passed to variable A and 4 is passed to variable B. And pointer is a variable which points to the address of another variable. So if you will match it with this example, the third method, width is a pointer, width is a pointer, width is a pointer whose data type is int, and height is a pointer whose data type is int. So when I create a pointer, the next statement should be the pointer variable is equal to new operator and the data type of a variable to which the pointer is pointing, which is int. So the same thing, width is a pointer and this pointer should point, this width should point to this width, which is a pointer, should point to variable A. This is what I want. So what I will use, width is equal to new operator and for A the data type is int. Similarly goes with height, or I will use this statement after this. We can use it here also, just to explain it, just for the explanation purpose I'm using this statement here. And star width is equal to A. Is this the same method? The same method? Okay. The only thing is here the pointer is declared soon before this, but here in this example the data member width is declared in the class body. Okay, so to initialize the pointer data members of a class, these steps are used. Similarly goes with height. Height is a pointer. I want this height to point to variable B whose data type is int and height is also int. So height is equal to new operator and the data type of variable B which is int, and star height is equal to B. So now pointer width is pointing to variable A and pointer height is pointing to variable B. Okay, so we have successfully initialized the data members of class ABC. The data members of class ABC are pointer variable width, pointer variable height. Okay, now for star width, for the pointer width, the value initialized is value of A. For pointer height, the value initialized is value of B. A was how much? 3 and B is how much? 4. So width is equal to 3, height is equal to 4. Okay. Now again, what I was telling you was the output of the program. So what will be the output of the program? As soon as the execution of the program always starts from the main function. In the main function, clear function is used, clear screen, and so it's going to just clear the output screen, nothing else it's going to do. Next statement is creating the object of a class ABC. So obj1. So as soon as we create the object, the constructor is called. So as soon as I'm creating the obj1, the constructor, this constructor will be called. This constructor will be called. So what is there in this constructor will get execute. It is only initialized. initializing the data members of the class, which is pointer width and pointer height. Okay, it's not going to print anything. Then this function is closed, it will be back here. Now next is obj2 is created. So we are creating second object, which is obj2. Again there is a creation of an object, so again the constructor will be called, and this 5 will be passed to variable a and 6 will be passed to variable b, and width is equal to a, which is 5, and height is equal to b, which will be 6. And it's not going to print anything, it's only initializing the data members of the object obj2. As we know that a class can have multiple objects, and each object has its own copy of data members and member functions. So for obj1, the data member width will be equal to 3, the data member height will be equal to 4. For obj2, the data member width will be equal to 5 and height will be equal to 6. Okay, so there till here there will be nothing on the output screen. The next statement is area. The next statement is going to print area of rectangle is. So on the output screen what you will see, the area of rectangle is what is going, and after this whatever is there in this will get printed, and after this what we can see is obj1 dot area. So that means that obj1 is calling area function. What is there in area function will get execute. So obj1 dot area, that means area function is invoked. So whatever is there in area function will get execute. What is there in the area function? It's going to return star width into star height. So for obj1, width is how much? 3 and height is 4. So width is star width is how much? 3. Star height is how much? 4. 3 into 4, 12. So it's going to print 12 here. So on the output screen what you will see, 12. This line ends, endl. Here the line ends. The next line will be printed in a new line. So this next statement, again it's going to print area of rectangle is. And then after this it's calling obj2 dot area. So the area function will be invoked for obj2. So what is there in the area function? Again in area function whatever is there will get execute. It's going to return width into height. For obj2 width is how much? 5, height is how much? 6. So 5 into 6, 5 6 are 30. So it's going to return 30, which is integer. That's why the return type of this function is int. So it's going to return 30. So here it will print 30 on the output screen. Endl, that means this line ends here. Get ch, end of the main function. So the output of this program, the expected output of this program should be this. So let me execute this program in Turbo C. This is the this is the program. Let's compile it and run it. So this is the expected output. This was the expected output. Okay, so what I was trying to tell you, okay, I have explained you the program. What about the destructor then? We were doing destructor. What about the destructor then? Destructors have the same name as class, which is preceded by tilde sign. Destructor and constructors are almost similar. The only difference is that destructor is preceded by tilde sign. Constructors also have this is a constructor. Constructors also have the same name as class. Destructor also have the same name as class. Constructors do not have any return type. Destructors also do not have any return type. So it is almost similar to the constructor. The destructor is almost similar to constructor, but destructor is preceded by the tilde sign. And destructor is used to destroy the invalid object. So as soon as this main function closes, or ends, or as soon as this program ends, so whatever memory allocated to obj1 and obj2 should be destroyed. Okay, so here in the destructor it's going to delete width and delete height. Got it? After this, after the end of the program, the destructor will be called and it will destroy whatever memory allocated to obj1 and obj2. One more thing I want to show you, or I'll show it to you in Turbo C. I will use one statement inside this destructor, which is cout. Destroy objects. So what I'm telling you is, when the main function ends, or we can say when the program ends, the destructor is called. So what is there in the destructor? It will delete the width, the memory allocated to width, the memory allocated to height, or destructor destroys the memory allocated to obj1 and obj2. So what I am saying is, when the program ends, this destructor is called. So other than these two statements, there is one more statement, cout. So as soon as the program ends, this cout statement should also print destroy objects in the output screen. So let me compile it. After these two statements, destroy object should be printed. Why it's not showing? Because currently program is in execution. The program has not end yet. When I will press enter, the program has end, because the last statement is getch. Getch is used to hold the output screen. So when I run this output screen has been held because of the getch. When I press enter, the program then ends. It comes out of the execution. That time the destructor will be called, and the memory allocated to width and the memory allocated to height will be deleted, and this statement will be executed. So if you want to see this output, either you press Alt 5. See, destroy object has been printed. And why to, okay, or you go into window, and print, click on output screen. So destroy objects has been printed. Why two times? Because there were two objects in the program. There are two objects, so the two objects should be destroyed. Then when two objects should be destroyed, then the destructor will be called twice. That's why when the destructor function will be called twice. So two times it is been printed in the output screen. Okay. So let's see what's written in the theory. We don't call the destructors explicitly, they are implicitly available, because till now the example which we have seen, we hadn't declared any destructor inside the program, so the destructor was implicitly available. It's not required to declare and define the destructor explicitly. They are called automatically for you, and there is only one destructor for each object. In this program, we had created two objects, so the destructor will be called twice. For each object, the destructor will be called. And there is only one destructor for each object. The name of the destructor is the name of the class and preceded by tilde sign. Okay, this we have seen in the example. Destructors take no arguments. As we have seen in the example here, there are no arguments in the destructor. Though constructors can take the arguments, but destructors cannot take the arguments. This is the second difference after the tilde sign. This is the second difference between the constructor and destructor. The destructors cannot take the arguments, but constructors can. It is even invalid to define one, because destructors are implicitly called at destruction time. You cannot specify the destructors. It is invalid. Okay? You have no chance to specify actual arguments. The third difference between the constructor and the destructor is constructors can be overloaded. We had seen an example of overloading constructor, but destructors cannot be overloaded. So overloading of destructor is not possible. Destruction of objects takes place when the object leaves its scope of the definition or is explicitly destroyed. Here we had explicitly destroyed. Explicitly we had defined and declared the destructor, so this we had done explicitly. If we wouldn't have explicitly defined the destructor, it would have called implicitly. Okay. Destructors are declared similar to constructors. Thus, they also use the name prefixed by tilde of the defining class. Okay. So this was an example of destructor. Next, static members. The static members we will discuss in the next class. For today, we will stop here.